Hello everyone, this video is the 10th in my series explaining AIME problems. In this video, I'll be talking about problems with different elements of geometry and the ways that they can be solved. I encourage you to pause throughout the video and try to solve the problems. There are some prerequisites that you need to know before watching this video. You should know most of the formulas relating to circles. You should also know most of the formulas for polygons, such as the sum of the angles and the angles of a regular polygon, etc. And you should also know the conditions required for triangles for similarity and the laws of sines and cosines. Let's start with the problem that involves triangle similarity. In rectangle ABCD, AB equals 100. Let E be the midpoint of AD. Given that line AC and line BE are perpendicular, find the greatest integer less than AD. Let's start by drawing a diagram. This is ABCD with AB and CD, and AB is equal to 100. We also have that E is the midpoint of AD, and that AC is perpendicular to BE. So, since we want ratios so that we can find BC, let's look for ratios. And the best way to do that is with similar triangles. So, we know that angle ABE is equal to 90 minus angle PBC, where we'll call this point P. Also, angle BCP is equal to 90 minus angle PBC, which is equal to angle ABE. And when I say equal to angle ABE, I mean the measure of angle ABE. And so there's a similar triangle there, since this is a right angle, and so is this. So we have that ABP is similar to BCP, and I mean triangle ABP and triangle BCP. Now let's try to find another triangle that ABP is similar to. We also have that angle ABE, well, it's equal to angle ABE, but in two different situations. In one, it's part of this triangle, but in another, it's part of this triangle. And so there's another triangle similarity there. So we have that triangle ABE is similar to triangle PBA. Thus, we have by ratios, and let's call BC x, and so AE is equal to x by 2. We have that 100 by x by 2 is equal to x by 100. This gives that 20,000 is equal to x squared, or x is equal to 100 root 2. And the smallest integer less than 100 root 2 is 141, which is our answer. Now let's do a problem that involves polygon angle sums. The degree measures of the angles in a convex 18-sided polygon form an increasing arithmetic sequence with integer values. Find the degree measure of the smallest angle. So, to start, let's find the sum of the angles in the 18-sided polygon. So the sum is equal to 180 times 18 minus 2, or 180 times 16, which equals 2880. Now, for the smallest angle, let's assign that to x, and each angle increases by d. So for the inequality that it is a convex 18-sided polygon, we have that x plus 17d, since the smallest angle is x and we need to add 17 times to get to the 18th angle, is less than 180. And we also have that x is greater than 0, and we'll define d to be greater than 0. So x plus d plus x plus 2d continued all the way to x plus 17d is equal to 2880. This simplifies to 18x plus 153d is equal to 2880. And from the inequality here, we have that 18x plus 306d is less than 3240. Now, we can subtract this from this, and we get that 153d is less than 360, or d is less than or equal to 2, since it has to be an integer value. And for x to be an integer value, d has to be even, so d equals 2. And from this, we get that x is equal to 143 degrees, which is our answer. Let's now do a problem that involves even more polygons. A rectangle has a side of length a and 36. A hinge is installed at each vertex of the rectangle and at the midpoint of each side of length 36. The sides of length a can be pressed toward each other, keeping those two sides parallel so that the rectangle becomes a convex hexagon, as shown. When the figure is a hexagon with the sides of length a parallel and separated by a distance of 24, the hexagon has the same area as the original rectangle. Find a squared. So let's fill in the information. We know that this is a and this is 36, and this is also a, and since this is at the midpoint, these sides are 18 and 18 here. This is a, and this is 24. So putting it here, we have that this is 24, and half of it is 12, and 12 here. By the Pythagorean theorem, this length is 6 root 5. So we can just use the area formula since the areas are equal. We get that 24a plus 24 times 6 root 5 over 2 times 2, which is just 1, is equal to 36a. So we get that 12a equals 24 times 6 root 5, or a is equal to 12 root 5. And for our answer for a squared, we get that a squared is equal to 720. Now let's do a problem that involves many circles. An equilateral triangle is inscribed in circle A, which has radius 10. Circle B with radius 3 is internally tangent to circle A at one vertex of T. Circles C and D, both with radius 2, are internally tangent to circle A at the other two vertices of T. Circles B, C, and D are all externally tangent to circle E, which has radius m by n, where m and n are relatively prime positive integers. Find m plus n. So before we start, let's just draw many lines in this diagram. So let's draw this line, this line, this line, and from here to C, here to D, and here to A. We can figure out many of these lengths and some of the angles too, and we can use law of cosines. So we have that AE is equal to r, where r is the radius of circle E, plus 6 minus 10, which equals r minus 4. We also have that AC is equal to 10 minus 2, or 8, and EC is equal to r plus 2. We also have angle CAE. Because all of these arc lengths are equal, we have that angle CAD is 120, or angle CAE is 60. Now, we can use the law of cosines on angle CAE, or triangle CAE. And this gives that r plus 2 squared is equal to r minus 4 squared plus 8 squared minus 2 times 8 times r minus 4 times cos 60. But cos 60 is just half, and this cancels with the 2. Now we can move r minus 4 squared to the other side to simplify the calculations, and we can use difference of squares to get that 6 times 2r minus 2 equals 64 minus 8r plus 32. Simplifying, we get that 12r minus 12 is equal to 96 minus 8r, where 20r is equal to 108. And this gives that r is equal to 27 over 5. And m plus n, in this case, is 32, which is our answer. Let's end with a problem that involves a triangle. In triangle ABC, AB equals 20 and AC equals 11. The angle bisector of angle A intersects BC at point D, and point M is the midpoint of AD. Let P be the point of the intersection of AC and BM. The ratio of CP to PA can be expressed in the form m divided by n, where m and n are relatively prime positive integers. Find m plus n. Before we can solve this problem, we need to know how the angle bisector can help us. The angle bisector theorem states that for a triangle ABC with angle bisector AD, CD divided by CA is equal to BD divided by BA. So, this divided by this is equal to this divided by this. Or, we can also write this as CD divided by DB is equal to CA divided by BA. Now, let's come back to the problem. First, let's draw a diagram. Let's say that this is triangle ABC, and the angle bisector of angle A intersects at point D. The middle is M, and BM intersects AC at P. We also know that AB is equal to 20 and AC equal to 11. Now, it's not too obvious how we can solve this problem, but maybe we can use a different trick. First, let's draw the line segment CM. Now, we see that it's partitioned into many areas, so maybe we can use areas to solve this problem. Let's say that the area of ABM is A, and so the area of MBD is also A, since these two sides are equal. And let's say that the area of AMC is B, and then the area of DMC is also B. And we know that B by A is equal to CD by BD because they have the same height, which is equal to 11 by 20 by the angle bisector theorem. So what length do we actually need? Well, let's look at ABC, but with B as the top angle. We want AP by AC, and AP by AC is also equal to APM, the area of APM, divided by the area of PMC. But it's also equal to the area of ABP divided by the area of PBC. And since these ratios are equal, we can subtract the numerators and the denominators. This gives that this is also equal to ABP minus APM, and I'm talking in areas, over PBC minus PMC. But this is just equal to A divided by A plus B. And we know what that is. But let's first flip the fraction, since that's an easier fraction. And we get that that's CA by PA, which equals A plus B by A. But A plus B by A is equal to 1 plus B by A, and this is equal to 1 plus 11 by 20. So this equals 31 divided by 20. So our final answer is 31 plus 20, or 51. Thank you for listening. Please like and subscribe, and remember to click the bell icon for more updates.